Okay, so this is Chapter 12, Section 2, constructing frequency distributions, construct histograms and frequency polygons, and construct stem and leaf displays and circle graphs. So this is all about displaying data. All right, so first of all, a piece of data is a single response to an experiment. The word data is plural. It says a frequency distribution is a listing of the observed values and the corresponding frequency of occurrence of each value. Okay, let's look at example 1. This will give you a better idea. So in example 1, it says the number of children per family is recorded for 64 families surveyed. Construct a frequency distribution of the following data. So what they're doing is what we're going to do is we're going to count how many times 0 is there, how many times 1, how many times 2, 3, 4, 5, 6, 7, 8, and 9. And basically what we're going to do is we're going to make a chart so we can see 0 occurs 8 times, 1 occurs 11, 2, 18, 3, 11, so on and so forth. And see the amount of frequencies that we have, if we were to add them up, would be 64, which was the amount of families that were surveyed. So that's what a frequency distribution is. It's counting how many times a particular value occurs in a set of data. Now there's multiple ways to represent this, and this is what we're going to go over next. Okay, so if we want to group them by classes, then what we have to do is we have to define the class width. So we have to define it as like 0 to 5, 6 to 10, 11 to 15, so on and so forth. Got to make sure the classes do not overlap, and each piece of data should belong only to one class. Okay? All right. So a frequency distribution of novels. So here's example 2. This is table 2.1 or 12.1 in the margin of this page, and the next page shows the number of copies sold for the 30 top-selling novels of all time. The number of copies sold is rounded to the nearest million. Construct a frequency distribution of the data, letting the first class be 50 to 94 million. And so here's some of the novels. You got Don Quixote, Tale of Two Cities, Harry Potter, The Hobbit, so on and so forth. So what happens here is this. If we have the first class at 50 to 94, then we generally want to make the widths the same. So 50 to 94 was a 24, a difference of 24. So what we're going to do is we're going to start the next class. And so if we ended the first class at 94, we're going to start the next class at 95. We're going to add 24 to it and go to 139. So that the next class, we would start at 140 and add 24 to it and go to, or 44, I'm sorry, 44, and go to 184. And we would continue that on. And so then what would happen is we would list the number of novels, because it's continuing over here. So like for instance, The Adventures of Pinocchio was 80 million, so it would go in the first class because it would go in between 50 and 94. Let's see. I don't see one any bigger, so the rest of these would be about the same. And notice that in our classes here at the end, we have only one that went 500 to 544 million. And if we look at it over here, we can see that Don Quixote sold 500 million copies. Okay? And so that's how we do our distribution. Okay, so the modal class of a frequency distribution is the class with the greatest frequency. So the modal class is the one that contains the most. The midpoint of a class, also called the class mark, is determined by adding the lower and upper class limits and dividing by the sum of 2. So in this case, going 50 and 94 for the first class, divide by 2. 72 is the middle of this class 50 to 94. Take 95 to 139, add them, divide by 2, we get 117. So 117 is the middle of this class here. So if we go to example 3, it says the following set of data represents the family income in thousands of dollars rounded to the nearest 100 of 15 randomly selected families. Construct a frequency distribution with the first class 31.5 to 37.6. So we'd have to start our next class at 37.7. And because we added 6.1 here, we got to add 6.1 to the 37.7, and we get 43.8. We'd have to continue that. 43.9, add 6.7. 6.1, and go on from there. Okay? And then we would list how many times the values came in. Okay? All right, constructing a histogram. All right, so if we go back to that example with the number of children per family, then what happens is we do what we call a bar graph, so to speak. So here's the number of families. Here's the number of children in the family. Basically what we do is 0, we would come up here to 8, and make a bar. Here we'd go to 1, come up here to 11, make a bar. So I'm getting that from here, okay? And that's how we make a histogram. And basically what a histogram does is if we look at it here, we can see that this is skewed to the right because we have a tail to the right. If it's skewed to the left, we'll have a tail to the left. And if it's normal, this little peak right here will be in the middle and it'll be fairly equal sides. Okay. Then we have stem and leaf plots. Stem and leaf plots is a tool that organizes and groups the data while allowing us to see the actual values that make up the data. So here's example 8. We have these values here. We got 20 visitors to Zion National Park. So we're going to put them in a stem and leaf plot. So what happens is, so with stem and leaf plots, we generally make the first number a tens, so to speak. So we have 20, we have 30s, we have 40s, we have 50s, we have 60s, we have some 70s, no 80s. So when I do my stems, this would represent 20. This would represent 30. This would represent 40, 50, 60, 70. And then what would happen is, like for this 29, I would put a 9 next to the 2. And so what would happen is that would represent 29. And put a 1 next to the 3, that would represent 31. And I also had 39, so I'd put a 9 here, which would represent 39. I keep doing that, a 2 here, and this represents 43, 47, 44, 45, 44. This represents 56, 59, 58, 50, 60, 62, 68, 71, 72. Those are the numbers that we have here. So now we have a stem and leaf plot that looks like this. And if you were to turn this around, you can actually see somewhat of a form of a histogram. And this would be termed as normally distributed because you have a peak in the middle and you have sort of the same tails on both left and right. So that would be considered to be normally distributed. And then we have our circle graph or pie graph. That's where each part of the circle represents a certain percentage. So for instance, if you have this right here where percents of respondents is here, then you have to divide your circle up to equal this percentage. And make sure you understand that the percentages should add up to equal 100. So like 38 and 5 is 43, this makes 57, this makes 74, this makes 100. So make sure your total percentage in a pie graph adds up to equal 100%.